Welcome to The Explainer. Okay, today we're unpacking one of the absolute most hotly debated, high-stakes architectural decisions that any technology team is ever going to face. We're talking about whether you should build your own tools, buy them from a vendor, or adopt open-source software. And look, this isn't just some abstract technical comparison. It is a fundamental economic decision. It literally dictates exactly where your organization's most precious resource, your engineering cycles, will be spent. Before we're done here, we're going to expose a hidden, often million-dollar consequence of choosing to build in-house without the right strategy in place. So, in this explainer, we're going to systematically dismantle the emotional biases that so often cloud our judgment around tool creation, and we'll look at this through a purely analytical lens. We're drawing our insights directly from Chapter 29 of the definitive guide, Observability Engineering. Let's get right to it.
Okay, let's dive into this. Here's our cognitive roadmap for today. First, the engineering bias. Second, the decision matrix. Third, factoring in open source. Fourth, the real costs of building. Fifth, the risks of buying software. And finally, number 6, the hybrid solution.
Section 1. The engineering bias.
So there's this brilliant quote from veteran tech leader Rick Clark that just perfectly captures the reality here. He says, "Engineers want to build just like surgeons want to cut." I absolutely love this quote because it hits right at the psychological core of the issue, right? I mean, let's be real. When you hire top-tier software engineers, they naturally want to tackle complex, massive systems. They want to build things from scratch. There is this deep, intrinsic badge of honor in creating a custom, bespoke piece of infrastructure. If you walk into a room full of developers right now and ask if they should build or buy a tool, their instinct is almost always going to be build. And you know what? That's completely natural. But we really have to recognize that this emotional appeal to build it ourselves is a massive driver of technical debt. Just think about how our industry works. We see promotion-driven development in action all the time. An engineer is honestly way more likely to get promoted for designing and deploying some highly complex custom telemetry pipeline than they are for simply signing a vendor contract that solves the exact same problem in like a single afternoon. The custom build looks amazing on a resume, the vendor contract, not so much. So we have to name this bias right up front. Acknowledging the psychological pull is literally the only way we can step back, strip the emotion out of the room, and make a decision based on actual business value rather than technical ego.
And that brings us to the core economic principle underpinning this entire explainer: opportunity cost. Resources are finite, period. When you choose to dedicate a team to building an internal observability tool, what potential business value did you just sacrifice? What product features aren't shipping today? Seriously, think about your current sprint. How many story points are dedicated to maintaining internal tools that your customers will never ever actually see? Now, you might be thinking, but wait, we have AI-assisted coding now. Writing code is essentially free. And hey, that might be true for the initial creation phase. Getting that very first iteration off the ground is definitely faster than ever. But the maintenance costs for AI-generated code are no different, and honestly, sometimes even higher than the code we write ourselves. Every single line of code is a liability. Every hour your team spends patching, updating, and maintaining a non-differentiating internal tool is an hour lost from building the core products that actually drive your market share. In today's highly competitive landscape, your engineering time is the single most expensive and scarce resource you have. Choosing to spend it on building something you could have just bought off the shelf is a massive opportunity cost that compounds over months and years, quietly draining your team's velocity.
Section 2. The decision matrix.
And this brilliantly illustrates how to bring some cold, hard logic into what is usually a super emotional debate. We're looking at a matrix that maps ubiquity on the vertical axis, so ranging from highly ubiquitous commodity items at the bottom to highly bespoke, unique needs at the top. On the horizontal axis, we have business value, ranging from low value on the left to high value core differentiators on the right. This gives us 4 very clear quadrants to categorize literally any piece of software in your org. In the upper right, we have build. This is high value and highly bespoke. This represents your core competency. It's the unique thing your company does that nobody else on the planet does. This absolutely justifies custom development. In the lower left, we have buy. This is low value and highly ubiquitous, meaning it's a total commodity. Think of things like identity management, logging infrastructure, or basic database hosting. This is standard stuff that doesn't differentiate you in the marketplace. Buy it. Do not waste a single engineering hour building it. In the upper left, we have should not exist. This is highly bespoke but provides basically zero business value. If you find software in your organization sitting in this quadrant, you need to obliterate it entirely. It is a prime example of engineering bias run completely amok. And finally, the lower right is decide. This is where high business value meets commodity. This is where the hardest, most interesting conversations actually happen and where your staff engineers need to weigh in heavily. It requires immense nuance. A robust telemetry pipeline is highly valuable to your business, but the underlying components to run it are largely commodities today. Deciding exactly how to navigate this specific quadrant is where architectural leadership really earns their paychecks.
So let's see how this matrix applies to real-world scenarios, all right? We've got 3 examples here. First up, Custom Service Level Objective, or SLO, tracking. Your job to be done here is meeting reliability targets. The verdict? Buy. Now, engineering teams often push back pretty hard here. You might think you're super special because you have 37 microservices, incredibly unique traffic patterns, and a hyper-complex deployment cycle. The truth? Newsflash, everyone has 37 microservices. Every single observability vendor on the market handles this. It is a pure commodity. Just buy it. Second, a front-end wrapper for OpenTelemetry. The job to be done here is making distributed tracing ergonomic and frictionless for your specific engineering context. The verdict? Build. Now notice the distinction here. You aren't writing a massive new distributed tracing backend database from scratch. You're just building a lightweight user experience layer on top of standard libraries, perfectly tailored to your team's unique workflows. That is bespoke and highly valuable for internal velocity. Third, cost attribution. The job is tracking your observability costs. The verdict here is actually a mix. Buy the platform, build the layer. Why this hybrid approach? Well, because accurately tracking observability costs often requires tying cloud spend directly back to individual engineering teams and specific microservices. That requires a deep, intimate understanding of your company's highly specific chargeback culture and organizational structure. A vendor simply can't know your org chart. So you buy the underlying data platform from a vendor, but you build the custom reporting and attribution layer right on top of it. The generalized pattern here is absolutely essential to internalize. Infrastructure and data storage, almost always buy. User experience and specialized workflow layers, almost always build.
Section 3. Factoring in open source.
Okay, we need to talk about a huge misconception in the industry right now, and that is the idea that open source software is free. Let me be clear, it is definitively not free. Open source is best understood as a shift in where you pay your costs. When you buy commercial off-the-shelf software, you pay upfront licensing and usage fees directly to a vendor, right? Simple. But when you adopt open source software, you're paying with your own engineering time and your own backend infrastructure. You're paying for the compute instances to host it and the storage to retain all that data. But more importantly, you're paying for network egress fees. When you're transferring massive amounts of telemetry data across different cloud regions or availability zones just to reach your central open source backend, those network fees can absolutely skyrocket. In fact, for observability pipelines, network egress can sometimes rival the cost of a vendor's licensing fee. The sheer volume of telemetry data generated by modern distributed systems is staggering. Processing millions of data points per second at scale is terrifyingly complex. Furthermore, you are on the hook for all the maintenance, the security patching, and the intricate systems integration work required to get it running smoothly with the rest of your stack. So in our matrix, open source lives in the adopt quadrant. It's a commodity that doesn't provide unique business value, but simply shifts your economic burden from predictable vendor invoices to completely unpredictable cloud infrastructure bills and payroll.
Section 4. The real costs of building.
So choosing to build internal infrastructure from scratch means you are absorbing some massive risks. We've already thoroughly discussed those huge opportunity costs. But what most teams completely overlook, and this is so crucial, is that building internal infrastructure requires rare product management expertise. The era of building rough, unpolished internal infrastructure and just sort of exposing the sharp edges to your software engineers, yeah, that era is over. Internal tools must be built, designed, and treated exactly like commercial products. A developer's cognitive load is already maxed out just trying to write business logic and understand the product domain. If you force them to use a clunky, poorly documented internal observability tool with a terrible interface, what do you think happens? They will actively avoid it. If you don't have a dedicated product manager determining actual use cases, optimizing developer cognitive load, and gathering iterative feedback, you will inevitably build something with a miserable user experience. The result? Abysmally low internal adoption. You've just invested months or even years of really expensive engineering time, drastically delaying value to the actual business, to create a tool that requires never-ending ongoing support and literally no one in your organization even wants to use it. Building without product management isn't just inefficient, it's a recipe for organizational resentment.
Section 5. The risks of buying software.
Now obviously, building is fraught with peril, but let's flip the coin and look at the other side. The buy quadrant isn't exactly some magical utopia either. It carries its own set of highly significant dangers. When you buy, you are essentially at the mercy of the vendor. First off, commercial products are explicitly built for wide audiences and general use cases, definitely not your highly specific edge cases. You also lack ultimate control.
Vendors get acquired by private equity firms, they suddenly pivot their product direction, or, worst case, they suffer massive, poorly timed outages right when you need your observability data the most. Furthermore, by outsourcing the problem entirely to a third party, your team fails to develop that deep in-house domain expertise regarding your own systems. But honestly, perhaps the most insidious risk of buying commercial observability software is dealing with pricing schemes that actively penalize curiosity. Observability isn't just for software engineers, right? It's for customer support, product managers, and design teams too. If a vendor charges on a strict per-seat basis or has this aggressive volume-based pricing model that spikes wildly when you query large datasets, it creates a culture of fear. Think about it. If an engineer is trying to debug a complex production issue, the absolute last thing they should be worried about is whether running a complex query is going to spike the monthly bill and get yelled at by finance. When pricing models penalize curiosity, engineers simply stop asking questions. They stop exploring the data. And when they stop exploring the data, the entire purpose of having an observability tool is destroyed. It completely prevents widespread, healthy tool adoption across your company.
Section 6. The hybrid solution.
So, we find ourselves at kind of an impasse, right? Building everything in-house is prohibitively expensive, distracts from core business goals, and often results in terrible internal adoption. But buying everything off the shelf can lead to dangerous vendor lock-in, missing features, and pricing models that actively penalize your engineers' curiosity. So where does that leave us? Well, the optimal path for most organizations actually lies in a buy and build mixture. This is the modern platform engineering model. Now, what's really interesting about this is how beautifully this architecture splits the responsibilities to leverage the strengths of both approaches. Here's how it works. You keep the instrumentation, the telemetry generation, and the data pipeline entirely in-house. You own your signals and your schema. This is incredibly protective. Because you own the instrumentation layer, you dictate exactly what data is collected and how it is formatted. You remain completely vendor agnostic at the code level. Then you send that standardized data out to an outsourced vendor who handles the brutal heavy lifting, the database hosting, the massive query performance requirements, and the back-end feature scaling. Processing and querying terabytes of distributed trace data in real time is a phenomenally difficult engineering challenge. Vendors do this exceptionally well. Your internal team likely will not. So you buy the underlying vendor to scale the backend, but you build the internal libraries, the deployment templates, and the friendly, tailored interfaces that make generating that data frictionless and completely idiomatic for your own engineers. It's the best of both worlds.
To summarize our core thesis for today, build as little custom software as absolutely possible. Your company's competitive advantage in the marketplace does not come from writing a marginally better tracing library or a slightly faster metric aggregation database. It comes from shipping features that your customers actually love and making observability work seamlessly for your organization. You achieve this by utilizing open standards, like OpenTelemetry. Standardizing on OpenTelemetry ensures that your instrumentation remains completely vendor-neutral. It makes your data valuable no matter what back-end vendor you might choose tomorrow, which fundamentally protects you from that vendor lock-in we discussed earlier. You purposefully buy the commodity capabilities, letting specialized vendors absorb the immense infrastructure costs of data storage and query engines. And most importantly, you focus your valuable, highly finite engineering energy on the integration, the developer experience, and driving the cultural, organizational change required to make observability a daily practice.
I want to leave you with a final, provocative thought. Take a hard look at your engineering team's current roadmap and ask yourself this question. Are you truly building a differentiator for your business, or are you just reinventing the wheel to satisfy an engineering bias? The next time a build versus buy conversation starts up in your architecture meetings, I want you to bring out this decision matrix. Check your technical egos at the door, rigorously calculate the true opportunity cost of maintenance, and relentlessly protect your engineering cycles for the work that truly matters to your customers. Thank you so much for joining me on this explainer, and hey, happy building or buying.